And now please welcome on stage Alish from Streamax. Please give him a round of applause.
Thank you and good evening. My name is Samer. I am representing Streamax, the manufacturer for mobile video surveillance systems. And today I am really happy to be here, with partners, to talk about what we are doing, with Wellness. And I believe, everyone agree with me that video now is a big demand in a fleet management business. Now we started with the location business, a position, and then move to a sensor inputs. And then we need to know what is exactly happening inside the cabin or outside the vehicle. Not only that, we also want to know, the system needs to extract information from the video automatically, and then that's what we call the AI technology. So, when it comes to video, every end user will have some challenge. He will have some risk. He will think video is a huge data. It's not like simple data you send some sensor inputs or location data. So this one needs to manage, need a server, need where to host the data, how much storage you need, this consumption data. Hardware system selection, which camera is really good for the vehicle, which camera can cover this angle of the vehicle. And also, most of the system doing video recording only. So video recording, when something happens, you go back, download the video, try to see by human eye what happened. You need something more advanced. You need to immediately take information out of the video and take action. And finally is after sales services. So this is basically usually end user risk. He feel like there is challenge. Today, let me put in your hand what we call the FD Vision. It's an application under Wayland, is integrated already, and this one is user friendly, very user friendly, almost look like Wayland interface, and it's cloud hosting. So here you can see this interface. I'm sure everyone know that this Wayland. You can go to applications. You just choose FD Vision, and then automatically will go to our interface, which is Wayland look like. And here you can manage everything. You will bring everything: drivers, vehicles, all the information you have. And of course, for example, you can see alerts, evidences. I'm going to tell you what is exactly about. When you click this one, this is for example how it looks like. When you choose a vehicle, here you have two vehicles online. If you choose one vehicle, you can locate the vehicle is on the map, and also you can open the live streaming. This is a live streaming coming directly from the car. So this click is for map, another one you can open live streaming. This have one channel inside, you can open live streaming and watch what is happening. Now, very important that it's not only about video, it's what is after video. You are getting video for recording, but also you need to take actions. Here, for example, you have you can zoom out, show all the data, all the camera channels together, and you have a cap for the video. You don't need to worry about data or data consumption if the end user forget to close the video streaming. This is another feature which is alerts. This is a live alerts. When it happens in the vehicle, automatically push the interface. Of course, you have different and plenty kind of alerts. Harsh braking, how the driver behavior, something related to panic alarm, something come from the video, which is what I'm going to show you now, and some I/O. All these come automatically here with priority, 3-star priority. You can manage this one. The really cool feature is the evidence. Evidence, when alarm happens, we create something called the evidence. Evidence is a collective data. It's a combination of data. It's a location, who's driving, which vehicle, in which place, and what is the I/O inputs, and also the video, all combined together. So this is very helpful when you are doing investigating something, getting proof for authorities or something. So all the data are coming together and synchronized. You can see the speed, you can get information from OBD, all synchronized together with one is about request. That one was automatically uploaded, but also you have the feature to request a video from the vehicle. Like you can just insert the date time from which time to which time, and you select the vehicle, request, it will go onto the queue, and then upload this video like 10 seconds, 20 seconds automatically to the server. Later you can find this one and play it back. You see, it's a queue. Now it's in the queue, waiting for upload, like from which time to which time, and then definitely like you have the, like user report, managing accounts, user, all is in the same interface. So you can create users with different permissions and authorities. So some can see the video, some can only generate the reports, and different authorities, permissions. Some for evidence, alerts, video streaming, you can define this one. Alarm as well, you can import this and export. And you can do the setting. Yeah, you can go to setting. Okay, so this is I just snapshot this morning, even that we are like very new to this video with WAN, but now we are actually more than 55% of all the video being connected on the WAN. We are not just standing there. We have a roadmap, we are working, adding more features to help end user and partners to manage this kind of business. We are working on a video playback, so you can play back directly the video from the device. It's not like you're requesting video. We are also working on managing the data. We have a module, special module to manage the data, to make sure you are not overcap this usage of data. You can share this SIM card data, always to manage. You know where is your data is consumed. And of course, a new feature we are, by end of this year, will implement is the facial ID, identify driver and passenger. Now, of course, for us, we have a different hardware. Like for each kind of vertical and each kind of vehicle, different hardware. Hardware means like even the MDDR and the camera as well. Totally different. Like if you look, it's a different design. Now, the thing that we have built in, that all the communication is coming on hardware. This means when you are connected, you will have a GPS built in, 4G, LTE, Wi-Fi, Bluetooth. You can connect to different sensors inside the vehicle, connect to the OBD, getting data from the vehicle, and then all data will push to our FT-Vision and web. This is a very important thing, that we have like a gyroscope sensor built in, but it's not only the gyroscope like XYZ, which direction happens, the G-force. We have our own algorithm to collect this data and then judge, is it a harsh braking, harsh acceleration, or is it like harsh turning, and so on. So this is a special design like algorithm. Now of course, plenty of integration, communication system, like go to the CAN, you have I/O for digital inputs, RS-232 and RS-485 as well. Now we come to the cool things like AI. When it comes to AI, everyone knows, I believe, like ADAS system, the advanced driving assistance system. So this one can detect if the vehicle changing a lane, or is not keeping enough safety distance, or is like a warning for accident. DSM is very important because it's focused on the driver. His behavior, like he is smoking, he is on the phone, texting, distraction, or even like blinking, something like this. BSD is very important for big trucks and buses, like blind spot detection. We focus on safety here, so we want to make sure, alert the driver that there is somebody in your blind spot. You need to make sure when you turn right or left. This is an example of how we forward collision. We are based on the camera. We are doing the AI technology to really identify the object and check the distance, and all these will come automatically to the driver. Give warning or to the driver, and this is not the only thing. We are pushing this data to the back end to help the management level to really get data to evaluate driver behavior. Behavior is not like one-time mistake. It's how this driver do the driving. This is another one for the headway monitoring warning, like he's keeping enough safe distance or not to the front car. This one about lane departure. So if the car like change the lane, you can see the lines. If he change the lane without giving the signal, this means he is not really fully covered. Maybe he's in a fatigue situation. Driver behavior is a camera focus on face. You can see that distraction. He is not focusing on the main road. Another one is like using the phone or texting, smoking, or even fatigue, like he's doing. Of course, this all is algorithm based on the video analytics, based on AI, artificial intelligence, to really identify. This is about the blind spot. So it will give like alert to a driver, like you have an area on the right side, for example, to detect. So it's identifying the humans and cars and bicycles, for example, motorcycle, not any object. Yeah, actually, I mean, for Streamax, we focus on the AI for the last 2 years. We invest too much for this. We have more than 500 engineers. This is a big engine, really big engine on something like this. And we have now almost 150,000 devices around the world using the AI technology to collect data and then push it to the deep level. Of course, we are everywhere. And thank you.
Mr. Samar, thank you for the wonderful presentation. I really like the way you mix between AI and telematics industry. Let me talk business. Is this solution workable in a market where your mobile data is really expensive? We are talking about 2 cameras working 24 hours, and then you showed us the synchronization of the data. So how many MB does it add to your normal bundle?
Okay, let me explain it this way. Actually, this we have a way to do it, like it's an offline AR technology. This means it's happened in the vehicle. This means you have a system in DVR, recording all the time, and getting the video all the time, and doing the AI in the car. So you only need to push a notification and maybe video for 5 seconds, 10 seconds for each case, each event for alert. We're not just pushing the stream all to the back end and to do the AI on the back end. This is the key point in this. So for a data consumption, I can tell you it's very fair because we are doing this for different verticals. Usually it does not consume too much because you are only pushing the data where there is event, where you really need to get this thing.
Exceptional cases only you are pushing.
Yes, yes. But anyway, the video is still there. You can request if on demand. I mean, like, for example, like something happened in the vehicle, you got alert, some warning or panic or something, then you can request streaming, open all the time. You can see, manage the case, finish, close the video.
So on average, how many MBs do you add, like in such exceptional cases, on average?
Now, I can tell you, like, for example, per month is almost, like maybe 100 MB is more than enough to cover around maybe like 50 alerts per month, 50 alerts. I'm saying this from our experience with different verticals, like school buses, cash transfer.
Great.
Can I also add something to that question? The thing is, you could, when it comes to ADAS, it's not always necessary that the clips be sent with the event. That is an option. But what is usually sent is one of the event IDs. And that is exactly the same payload as any GPS tracking device would be. It would be just sending maybe a number, but usually some devices will send a event ID, like 1, 2, 2, probably 15 or 20. So that's what will go. And if you require to query back to the device for that video, then yes, it would happen. And that also would not be, if you have 10 people querying the same device, you will not get 10 screens. You will go into the RTSP server, and the RTSP server will broadcast to the other systems. So that's how it works.
Right.
Okay, thank you. I believe Samir had a question.
I understand that it's per event, per violation, per whatever, but I need, if you can give me, a specific answer, because we get asked this all the time. What is the data consumed per channel if I have a project that needs online stream? Do you have a figure that we can depend on and sell or market? For one channel, for example, 720p based on H.264 per 1 hour. How many gigabytes is consumed?
For 1 hour, 720p, it will reach like maybe 500 MB.
500.
But for streaming, to be honest, I mean, you are recording 720p, but usually for stream there is another technology, like you have a free stream camera. Usually you have two streams, one is for recording and one is for uploading, like streaming. So usually what you stream is not 720p. We are using some kind of technology to adapt, not only compress, it's adapt to the network. Because sometimes this is a mobility, like a car is moving, right? Sometimes you have a good signal, sometimes you do not have a good signal. So for the end user not to see this like clipping or stop videos, we use the bandwidth or the bit rate is dynamic bit rate. It's not like always per hour it will cost you this much of data. However, it's not 720p, this for sure. 720p is for recording, but for streaming, you don't need a 720p. We go for WD1 or CIF sometimes, depends on what is really the case, you know, what they need to see on the live stream.
Okay, thank you.
Sorry, there was a question here.
We have discussed before about your solution, and say you can upload the data by Wi-Fi when it reaches the warehouse or whatever.
Right.
Can the server where the data will store connect with Wi-Fi, so I can request the clips or whatever playback from the server, not from the device itself?
You mean you push the data over Wi-Fi to a server and then you connect these to wireless server, right?
Yes.
Like here.
Can I do?
Of course, but the current application, what we are offering is a cloud-based. It's not like a standalone server that you can install. Currently, it's a cloud-based. So this installation, you need to put it on a cloud now. This FT Vision server, you need to put it on a cloud.
On your cloud?
Currently on our cloud, but of course, for a project, you can put it on your cloud. It's fine.
So I can make storage in my customer site, and
Yes.
he can connect with this.
Yes. And however, Wi-Fi uploading is not related like if it is a standalone like server or cloud server. Both can work because it's only a channel to push the data to the cloud or to the server.
We have some project. The customer need the data will be local.
Totally understand. This is especially limited if most of the big projects they say they need a local data. And that's why this can support, but they need to host the data at the end. They need like to put this server.